Cool. So, welcome everyone. I think we're on to our fifth workshop now in Developer DAO. We've had some really interesting things happen already, or things being shown already around sort of crypto OPSEC security, deploying React front ends to Arweave, and then a super deep dive into data structures on Ethereum. All of this has really been made possible by Ropats and also Lena, who's on this call, sort of wrangling and organising to make this happen. So massive kudos to them. Thank you very, very much. Today we have Kenny with us, who's going to be doing a talk on writing an NFT smart contract in Stacks and Clarity. So big thanks to Kenny. It's going to be an interactive session, so make sure you're ready to kind of get involved, and Kenny's quite happy to have questions as he goes along. If you've got any, feel free to ask them or drop them in the chat, and I'll try and pick them up and hand them over to Kenny. But yeah, enough of me. Welcome, Kenny. If you want to kind of introduce yourself and tell people a little bit about you and kind of what's happening today, and kind of kick on with the workshop, that would be amazing.
Cool. Yeah, thank you. So yeah, I'm Kenny. Right now, I'm working as the developer advocate for the Stacks Foundation, and so we focus a lot on like grants and funding projects and education, stuff like that. So, quick intro, been a developer for about 9-10 years. Started getting into Web3 stuff a few years ago. Actually started off with Ethereum and Solidity development. And then found Stacks and ended up really just being drawn to it and liking it for a lot of the reasons that I'll go over today while we talk about it. And then, yeah, started creating some content. Stacks Foundation reached out to me and ended up moving into the developer advocate role for them. But so, yeah, let me share my screen and we'll kind of start jumping into stuff. Cool. Is that showing up for everybody?
It's coming through for me.
Wait, okay, cool. So yeah, today we're just kind of gonna a little bit of a two-part workshop. We're gonna kind of start off by going over Stacks, what it is, what problem it solves, why people might want to build on it, and then we're kind of gonna switch it up a little bit and do an interactive code demo for Clarity, which is the smart contract language on Stacks, which is one of the big reasons why I was drawn to it. So we'll kind of go over what the unique features of Clarity are, how to write on it, and then specifically we'll be building just a super simple NFT project. So, before we do that, just in case anybody hasn't yet, I'm going to post a link in the chat. This is the tool that we use in the Stacks ecosystem. It's basically our version of Hardhat. This is kind of what we use to get up local smart contract environments up and running. So if you do want to take part in the interactive session on Clarity, go ahead and get that installed and make sure you can run it successfully, because we'll be using that. We'll be using that when we got our smart contract going. So if anybody hasn't done that yet, you can go ahead and do that while I'm kind of going through this intro part. So first up, what exactly is Stacks? So short version, elevator pitch is Stacks enable smart contracts in Web3 on top of Bitcoin. A few things that it's not is it's not a layer 2 like Lightning. So whereas a layer 2 just scales existing functionality, it can't necessarily add new functionality. So that's kind of the differentiating factor between a layer 1 and layer 2 in this case. So it is a layer 1, its own sovereign blockchain. It has its own token, but it settles to Bitcoin. And the way it does that is through the proof of transfer consensus mechanism, which we'll get to in just a second. Excuse me, but this diagram kind of shows like the general ethos for Stacks and what its goal is and where it fits in the ecosystem. So up until pretty recently, Bitcoin was just kind of seen as digital gold. It kind of originated blockchain technology. It's the original blockchain, but it didn't really do much besides just be money. And then Ethereum came around and kind of proved that there's actually a lot of demand and a lot of use cases for using blockchain technology for more dynamic stuff via smart contracts. But the problem with doing that on Bitcoin is that Bitcoin is more designed to be the super simple, secure settlement layer, so it's always been seen as kind of boring. But what we can do, and where Stacks comes in, is rather than combining the money layer and the settlement layer into one, we kind of take the approach of let's have the money and settlement layer be one thing, and then let's have the computation smart contract layer be a separate thing. So we kind of have this separation of concerns, which allows Bitcoin to stay simple, stay boring, but also still serve as the foundation on which we can build a lot of Web3 stuff on top of. So in that case, it kind of takes the whole Bitcoin is boring thing and turns it from a disadvantage into a strength, because then we can have that separation of concerns, which helps us eliminate a lot of complexity. And this really involves kind of shifting the way you think about Bitcoin from being just digital gold and just money into more of like a foundational, super simple, robust settlement layer. So that's kind of the big picture, like ethos of Stacks. And how it does this is with a consensus mechanism called proof of transfer. So this is how Stacks this is how it's a layer 1 blockchain that's also connected to Bitcoin at the same time. So basically how this works is, if you start at the Bitcoin level, the way that Bitcoin mining works with proof of work is you take energy, you spend energy for a chance at mining a new Bitcoin block. So you're taking that external resource, you're performing the computations, and then you get a chance at mining a new Bitcoin block, but you have to spend that external resource of energy in order to mine that Bitcoin block. And basically what Stacks does is proof of transfer is it takes that one level further to then it makes it so that you are spending Bitcoin in order for the chance to mine a new Stacks block. So what Stacks miners will do is, if you look at the first part of this diagram, starting off with miner, is they will spend Bitcoin, and what that does is it will put them into a verifiable weighted random function, meaning that the more Bitcoin you spend, the higher likelihood you have to mine the next block. Doesn't mean that the highest amount of Bitcoin will mine the next block, but it weights the randomized function a little bit more. And then what happens is, instead of that Bitcoin getting burned, it actually gets transferred to stackers. And stackers are basically people that lock up their stacks on the Stacks network to contribute to the economic security and to contribute as sort of like a signal to miners for what the real chain is, just to help the economic value of it boost. It does not have any impact on validation or consensus. So it's different from proof of stake in that way. The purpose of stacking is twofold. One is on the chain side, contributes to the economic security of the network, but then stackers also get rewarded in Bitcoin that comes from those miners. So that's the transfer in the proof of transfer part. Right now, so if you lock up your stacks, right now you earn about a 10% yield on that stacks. And it's a little bit different from the way that yield in a DeFi protocol might work, because it's actually just existing Bitcoin being transferred to stackers. There's no like new currency being created as part of this process. And then what'll happen there is the Stacks miner will then write the block to the Stacks chain, and what happens then with its connection to Bitcoin is the hash of every Stacks block gets written to the Bitcoin chain. So Bitcoin doesn't necessarily need to know Stacks exists or even really care about it, because all we're doing is we're actually just creating Bitcoin transactions and writing a Stacks block header hash to those transactions. So the benefit that we get from this is twofold. One, we'll get into this a little bit more when we start talking about Clarity, but it allows Stacks to have visibility into the Bitcoin chain, so we can actually use Bitcoin transactions to trigger actions happening on the Stacks smart contract network. And then two, this allows us to leverage some of Bitcoin's security, because while it's not as secure or as decentralized as Bitcoin, what it does do is it ensures that the history of the Stacks chain is tied to the history of the Bitcoin chain, which means that if you wanted to try to reorg the Stacks chain and do a reorg attack, you would have to also be able to reorg the Bitcoin chain, because if you didn't, then the history of the chains wouldn't match. So that's how it leverages some of that Bitcoin security.
Can I ask a question, Kenny?
Yeah, go for it.
So, like, say you someone didn't inherently trust Stacks, they're only really trusting them since the last block, because you're shifting that trust into Bitcoin when you put that transaction hash into Bitcoin. Does that make sense?
So I think it makes sense. So Stacks does still have its own history and chain, and so there is maybe I'm misunderstanding the question, but you do kind of, if you want to use Stacks, you do have to trust both. So you would have to trust the Stacks network, and you would have to trust the Bitcoin network at the same time. The purpose of the writing it to the Bitcoin chain is more just for to tie the history to it. Is that what you were asking?
Yeah, I think so. I think it gives me the answer. I think it was so a hypothetical scenario, if someone tried to fork the Stacks chain onto a different path, right? That you would be able to know which one's the right one based on which hashes have been put in. Yeah. Okay, cool.
Yep. Yeah. So that actually kind of brings up a good point. This part of what's written into the source code of Stacks is writing to the Bitcoin chain. So that makes it extremely difficult to create. The other thing you can't do with Stacks is you can't create a private history of the chain and then try to attack it that way. It's not possible to create a private Stacks chain because you have to record to the Bitcoin chain as part of the mining process. So technically, you could fork the code because it's open source and you could change it so that it didn't write to the Bitcoin chain, but then it wouldn't be Stacks anymore. It would be something else. It'd be something different. So in the future, let's say hypothetically, some other proof of work chain overtakes Bitcoin. With community consensus, the Stacks blockchain could technically be rewritten to attach to that new proof of work chain. The reason that it's attached to Bitcoin is just because at the moment, that's the longest running, most secure, most decentralized chain. I know there people would argue that, but that's at least the thinking behind it. So yeah, I think that answers that part of the question.
Yeah, that was perfect, mate. Thank you.
Yeah. Okay, cool. So one of the other things that is super exciting, this is still in the early stages, but one of the things that's super exciting is the potential to, yeah.
You're still showing the same slide, by the way, FYI. I wasn't sure if you are.
Okay, cool. Let me see. I think we'll keep on this one for now. Okay. Just one more last thing on kind of what this connection to Bitcoin allows us to do is basically have like DeFi on Bitcoin, but the big thing right now is that you can't do that without moving your Bitcoin to a different chain. So whether that's wrapped Bitcoin or if you use something like Liquid, you can't actually do anything. Bitcoin's not a productive asset unless you move it off chain. The big long-term, big picture unlock for Stacks is being able to have Bitcoin DeFi without your Bitcoin ever having to leave the Bitcoin chain, and eventually without it ever having to leave your own a Bitcoin address that you own. And we can do that one way right now by reading the Bitcoin chain and triggering Stack smart contracts there. But the big problem to be solved still, that's one of the high priorities in the ecosystem, is how do we write back to Bitcoin? And that's a pretty complex problem to solve without having to modify the Bitcoin chain at all. But that's sort of like the big long-term, one of the really big picture goals and long-term goals that Stacks has is that. And there's some people in the ecosystem that are working on that. Like there's a project called Zest Protocol that's basically working on institutional lending and borrowing with Bitcoin, but without your Bitcoin ever having to leave the chain. So that's one of the super cool projects, but technically that it's possible. We're just working on the actual practical implementation of actually doing it, but that's one of the long-term things that a lot of people are excited about. So moving on a little bit. So why Stacks? I'll kind of get into like why people might want to build on it, what drew me to it, what some of the differences are between it and some other chains. The first thing we kind of went over a little bit is the separation of concerns. So one of the downsides of having the money and settlement layer combined with the smart contract layer is that it just introduces a lot of complexity. And if that's handled correctly, then it's no problem, but it just introduces a lot of avenues for attack that don't necessarily exist if you separate those two layers. And so that was one of the things that really drew me to Stacks was I liked this idea of having the hard money, the hard settlement layer be one thing and the smart contract programming layer be another thing, because if an attack or something happens on the Stacks chain, that doesn't necessarily affect the Bitcoin chain. So if we view Bitcoin as this like global reserve currency that also serves as a settlement layer, that getting attacked would be like, if with the Bitcoin vision at least, that would be really, really, really bad because it would be a global reserve currency being attacked and undermined. But if we separate out those two layers, then we get the best of both worlds because we still get the functionality of the smart contracts. But if something happens on the Stacks network, it doesn't destroy the Bitcoin network necessarily. So I like that separation of concerns. A lot of the developers that build on Stacks have listed that as one of the reasons they like it too. Another reason is if you like Bitcoin, if you like proof of work, but you thought it was boring, this is kind of where I was at when I first got into Web3, is I thought Bitcoin was great. I thought it was a perfect system for kind of a hard money, but I didn't really see anything that I could do with it. So I started building on Ethereum Solidity. Well, Stacks kind of solves that problem, makes it so that people can actually start doing productive things with Bitcoin, but without making the Bitcoin people mad and trying to change the chain. And then one of the other things I just kind of want to touch on a little bit, a lot of people's concerns with Bitcoin revolve around the energy usage, as it does. A proof of work chain obviously uses monumentally more energy than a proof of stake chain. And one of the other reasons I like Stacks is because it basically recycles that energy, because the only energy required to run Stacks is just whatever energy is required to run your Stacks node, which could be run on a Raspberry Pi. So one of the core engineers for the Stacks chain has this quote that I like a lot, where he basically says Bitcoin isn't a waste of energy, it's just underutilized. So one of the things I talk about with energy usage is there are things that we use every single day that use more energy than the Bitcoin network, like just basic household appliances, when taken together, use more energy than the Bitcoin network. So if we're viewing it as a cost-benefit analysis, if Bitcoin does serve as like an immutable hard money and a permanent ledger and also a settlement layer for tons of different decentralized computing, then that energy conversation starts to look a little bit different. Especially when this is not something we'll get into in this talk because it's extremely complex and nuanced, but if you look at the debate between proof of stake and proof of work, I think it's pretty clear that it's going to be a multi-chain world and we're going to have both. And so there are different costs and benefits to both, but this kind of helps to add additional functionality to a proof of work chain without having to change that energy footprint any more than it already is. The other big thing is that it's pretty new, and so there's lots of opportunities available right now. The Stacks chain mainnet actually just launched at the very beginning of last year, so it's a pretty new chain. Lots of people looking for stuff to build, lots of opportunities for developers that are curious, want to start building stuff, contributing to the ecosystem. One thing is that, like, because it's kind of a double-edged sword, because we're pretty far behind the Ethereum ecosystem as far as age, it means that there's tons of opportunity to build stuff, but that means that's because a lot of the stuff that exists in the Ethereum ecosystem doesn't exist yet in the Stacks ecosystem. So like you're kind of in even more of a Wild West area than you are in normal Web3 anyway, because a lot of the stuff doesn't exist. But if you're kind of the person that likes to build that stuff, then it's great. And then it's this focus on safety and security at the base level. So we've learned a ton about smart contracts, vulnerabilities, hacks from the existing Web3 world, Ethereum, Solidity. And so what Stacks and Clarity, which we'll get into in a minute, kind of does is it takes a lot of the lessons learned from that and kind of stands on the shoulders of the Solidity and Web3 giants to kind of make some adjustments to how we develop smart contracts, taking some of those lessons that we've learned and seeing how we can eliminate some of those safety issues at the language level, so that it's not on the developer to try and avoid some of this stuff. It literally is not, it's not possible in the smart contract language. So we'll get into that a little bit when we talk about Clarity, which we'll go ahead and move into right now. So I'll kind of go over like a brief overview of Clarity, and then we'll move into the code demo. But basically, Clarity is designed for high stakes contracts, and so it's got safety and security built in. So we'll go over some of these features, and then we'll kind of look at a little bit of them when we go into the code demo. But at a high level, Clarity is made to be predictable, so it uses super precise syntax, so you know exactly what your contract's going to do. There's no compiler, it's interpreted, not compiled, so when you write a smart contract, that gets broadcasted and posted to the chain exactly as it's written, so that eliminates another little area of complexity right there, and makes it so that you can go to an Explorer and view the contract right there exactly how it was written without needing to go through a decompiler to try to see what that looks like. It's decidable, which is a super complex topic, again with lots of debate, but the primary thing to understand here is that Solidity is Turing complete and Clarity is not Turing complete. Simple version of what that means is basically you can't have unbounded loops in Clarity, which means that a secondary benefit of that is that you can't run out of gas in the middle of a call. So since there's no unbounded loops before you deploy a contract or run a transaction, you can analyze the call graph to basically see exactly what's going to happen and exactly how much gas it's going to cost. So the problem of submitting a transaction and then running out of gas in the middle of it and then losing out on all the gas that's been spent so far doesn't happen in Clarity. The other benefit of that is that there's no unbounded loops. This requires kind of people to think about coding a little bit differently. You kind of have to focus on more of iteration over looping, but it just eliminates another one of the vulnerabilities that can kind of catch developers sometimes. We went over the interpreted, not compiled. And then so Stacks, this is not a Clarity feature, this is a Stacks feature. It has these things called post conditions. And what this does is it allows the client side, so this would typically be like the client side developer, to add in conditions that have to be met or the transaction will abort. So as an example, let's say that you're buying an NFT and you expect to pay 50 stacks and you expect to get an NFT in return. Well, what these post conditions will do is from the client side, so from the user side, as you're initiating the transaction, those conditions will be sent in along with the transaction. And if those things don't happen, the transaction will abort and you'll only be out the transaction fee. So this is kind of an extra safeguard to help prevent people from interacting with the contract that's going to do something unexpected, whether that's just an accident or whether it's something malicious. Either way, it just gives a little bit more security control on the user side of things. Custom token types are one of the things we'll be looking at today. So you don't need to pull in external libraries. There are built-in functions for creating custom fungible tokens and NFTs. We'll look at the NFT one today. There's no unchecked responses, so all calls are required to be handled with either a success or an error response, so there's not going to be any confusing like things that silently fail, but you have to go hunt down what actually happened. And this one's actually one of my favorites, is it favors composition over inheritance. So Clarity is not class-based, so there's no class trees that you have to kind of follow and pull down that have implicitly hidden functionality. This is one of the things that I was kind of interesting because when I first started coding in Clarity, I thought it was kind of annoying. But then once I started to build things on it, the more I appreciated it, is it's this trade-off of focusing on security and no pun intended clarity over like efficiency of code. And so what that ends up doing is you end up having to write more verbose code, but that's because you have to write out every single thing that the smart contract is doing. There's not going to be anything that's happening that's not visible directly there line by line in the smart contract. And so this can also eliminate a lot of issues that people can have if they're using functionality that's inheriting from a class that they may not have direct visibility into. And so another one of those things where it's just kind of a trade-off between concise code versus super clear, even if a little bit longer code. And it requires the developer to think through every single line of what they're doing. Kind of a secondary benefit of this is that it makes it much easier to audit code because literally everything the smart contract is doing is written right there in the smart contract. And so instead what Clarity uses are traits, which are basically like smart contract templates, and we'll be using one of those today for the NFT. We'll kind of look at what that looks like.
Does that, Kenny, does that mean that it doesn't have like a package manager built in, or there's like no way to import, say like you have like Open Zeppelin in Ethereum, can you do similar kind of things, or is it expected that you write all of that stuff and then like the core functionality is written into Clarity itself?
Yeah, so more towards the second one. Basically, it's expected that every piece of functionality that your smart contract actually performs has to be written in by the developer, which again is one of those things that some people might hate because that obviously makes more work for the developer. But my perspective on it there, which kind of shifted the more I started working with Clarity, is that for something like a transparent, immutable blockchain that's most of the time handling some sort of financial asset, that's actually a benefit, and we should embrace that sort of like needing to explicitly type out everything that's happening. The thing that Clarity uses instead are called traits, and what this basically does is this is more of like this will probably make more sense once we get into the demo, but it basically serves as like a standard that a smart contract will have to adhere to. So like for the NFT trait, it will enforce that the smart contract has certain functions that take in certain values and return certain things, but it will still require the developer to actually implement that functionality. And the primary purpose of the traits are just to make sure that we can have sort of inter-contract operability so that we can have standards among community so that different marketplaces aren't all interacting with NFTs in different ways. But we still have the explicit typed out functionality of what the smart contract is actually doing. So that part, the traits part, is kind of a middle ground, but yeah, it's definitely more towards like there's no like package manager pulling in libraries or anything like that. You can implement traits, but otherwise you kind of
that makes sense. It gives me kind of like using TypeScript and then actually using TypeScript feels when you get people that know what they're doing and you have to actually have to write everything. But that I love that now. I hated it at the start, but it is what it is.
Yeah, that's kind of what it was with Clarity too. It's like, well, this is kind of annoying, and then you realize, oh, okay, I actually kind of get why this might be smart. But
I think we had another question coming in then as well. I'm not sure who it was.
Yeah, so just a question, like you said, like there is no compiler for this Clarity. So how are we going to test it without deploying it on the chain, or like we have to deploy it on the test net and then have to test it?
Nope. So that's kind of what we'll get into that a little bit in the demo, but there's a tool called Clarinet, which is what I linked to in the chat, and basically what that will do is that has a couple different commands. It has Clarinet console, which is what we'll be using today. That will just kind of allow you to call contracts directly. But it also has Clarinet integrate, and what that will allow you to do is it will allow you to set up an entire Stacks mocknet on your local machine, and it actually ends up making locally testing contracts. It makes it a little bit smoother of a developer experience because you don't have to wait for the compiler to test your contracts locally. You can just test them as you write and save them. So no, there is a test net that you can deploy and test on there, but there are also tools to help you kind of get a local mocknet set up so that you don't have to do it that way. I actually like the local development process using Clarinet better than other things I've used because it's just a lot smoother and faster when you don't have that extra compiler step. And then one other thing I want to address just before we quickly jump into the code demo is I don't want to make it sound like I see a lot of I don't know what the right word is, like animosity or just arguments between like Clarity developers and Solidity developers of I don't want to overemphasize what Clarity does and make it sound like it just makes it impossible to write bad contracts or that all of this stuff is impossible in Solidity, because that's not true. Like EtherScan has their decompiler that you can do. Solidity has a reentrancy guard. Oh, that was one of the other things I forgot to mention. There's no reentrancy allowed in Clarity, so it just disallows it at the language level. You just can't do it. But like there's a reentrancy guard in Solidity. So the purpose here is not to say that like Clarity can do all these things that Solidity can't, and therefore Clarity is better than Solidity. The point is to say that Clarity takes the hyper secure, hyper safe approach where rather than needing to rely on the developer to opt into all of these secure features and to trust that the developer knows how to write good, safe code, Clarity more takes the approach of let's enforce this stuff at the language level and make it so that this stuff isn't even an option. So it's just a different approach to coding into smart contract development. So yeah, just kind of wanted to say that. But with that, let's get into the code demo. First thing I'll do is there's this, did it switch screens to the browser? Clarity tools.
Yeah, you're up, man. You're good.
Awesome. So I'll just kind of go over like the super high level basics of the language because it is likely different, pretty different than what a lot of people have used before, where Solidity is relatively similar to like the syntax and style of JavaScript. Clarity is more similar to like Lisp. So it's list oriented and there's lots of parentheses. So like if we look at the top function up here, this define read only, hello, what we're doing here is everything is wrapped in parentheses. And so this first argument here, define read only, this is saying we're defining a read only function. We're going to call it hello. And what that read only function is going to do is it's going to return this hello stack string. So then down here, when we call that function, you can see right here on the left, that's what it's returning there. And this is kind of, you'll see this over and over in Clarity. It's really just lists inside lists, and everything is a function and a parameter passed to that function. So down here at the next level, this is where this is kind of one of the weirder parts of it, but also where the concept kind of becomes the most clear is with numerical operators. So with, another language like JavaScript or Solidity, you would just do, put this out, 4 plus 5, and that would return 9. But in Clarity, what we're doing right here is we're calling a function that has a name of the addition sign, and we're passing in the numbers 4 and 5 as parameters to that function. And then you can see right below that, concat kind of works the same way. This will also get a little bit more clear as we kind of go through the code demo, but this is just kind of a big shift in thinking and coding that is another one of those things that will feel a little bit weird at first, but is nice the more that you work in it. So that's kind of the super high level introduction to just kind of the style of the language and what makes it a little bit different.
Kenny, is there a language that this is like influenced by that people may be aware of? Like it feels quite functional, but I've not done much functional programming, so I wouldn't know.
It's definitely got more functional tendencies. It's very heavily influenced by Lisp. So I don't know if anybody has experience there. I don't. This is Clarity was my first exposure to this style of programming. I just did almost exclusively JavaScript before I started getting into Clarity development. So it's definitely a shift in thinking for me, but yeah, it has very much like functional tendencies, and it's heavily based on Lisp. kind of the main
Cool.
influence.
And Lisp is used for like lots of compilers and stuff, right? For those similar kind of features.
Yeah, exactly. And that's what this was, a very like how do you want to say, like academic type influenced language. Like a lot of the people that wrote this were computer science PhDs, people that get like really into the weeds on like language design and exactly what things should be used for. But yeah, Lisp was what it was based on. It's kind of weird to get used to at first, but again, it really helps just lay things out line by line. The other thing you'll see here is that there's not really like, there's no nesting. Everything just happens at the root level of the contract. We'll get into building a smart contract right now, but yeah, there's no like opening, closing brackets, no classes, that kind of stuff. You kind of just list out everything at the root level. So we'll get into a little bit more of that right now. So I'm going to jump over to Hyper.
So we're not seeing your Hyper now, dude.
Oh, you're not? Okay.
No.
What's up there?
So you may need to, so on Discord, when you're sharing your screen, you can like share an app, or you can share like an entire display. So in the bottom left on your Discord, where you're connected to the voice channel, there's like a screen button. And if you click that, you'll get like a modal, and then there's like applications and screens, there's like tabs. And then you probably want to switch to a screen.
Well, I thought I had done that before. I must have hit the wrong one.
Who knows, dude?
Okay. Hyper showing up now?
Yeah, we got you.
Cool, sweet. Okay. We've only been here for a second, and we'll switch to VS Code. But so if you installed Clarinet and have it running and everything, the first thing we're going to do is set up a new project. So we'll do that with Clarinet new, and we're going to make an NFT. It's going to be called Aardvarks. So we're going to create that new project. This is just a question. So Hero is the developer tooling company that created Clarinet. They do a lot of the developer tools in the Stacks ecosystem. This is just them asking, do you want some high-level usage information? Totally up to you. I always do yes, but you don't have to. So then I'm going to go ahead and open this in VS Code. This is on the other screen, so let me pull this over real quick. Okay, and VS Code showing up. Looks like it.
Yeah, we got you, man.
Sweet. All right. So first thing we want to do here is I'm going to open up the terminal here, and we're going to immediately implement the trait that we were talking about. So the way that traits work in Stacks is they're actually contracts that get deployed to mainnet. So if I open this up in the Stacks Explorer, I'll post this link in the chat in case anybody's curious. But this is the NFT trait that we'll actually use. And basically what this is doing right here is we have this define trait function. And what this is doing is this is setting up the template for the functions that our smart contract needs to implement. So basically, in order to adhere to this trait, which is kind of just like it's a community standard, is our smart contract needs to implement all of these functions, and they need to follow this structure. So at this, take this first one, for example. What this is saying is we need to implement a function called get last token ID. It won't take in any parameters, but it will return a response type and then a uint, which is an unsigned integer, which just means a positive integer. Down here, the next one, we need to implement a function called Get Token Uri. This will take in a uint as a parameter, and then it will return a response type. And this is getting into the weeds a little bit on the types. I'm going to provide links after this in case anybody wants to dive deeper into this stuff, because we won't have time to cover all of it. But this is an optional type. Optional types are basically used when you don't know exactly what's going to be returned. They could return a value or they could return an error, but they always have to return something. And this is going to return a string with a length of 256 and then a uint. And so this is in charge of returning the metadata, and we'll kind of get into how to implement all these, but that's what this trait definition is going to look like. It's going to define the function name, the parameter it needs to take in, the parameter type it needs to take in, and then the response type that needs to be returned from that. So what we can do in Clarinet is we can actually implement this requirement. We can write Clarinet requirements add, and then we are going to paste in the contract address for that trait right here. And this is the one that I just linked to. Then we can hit enter there. And what this did right here, updated clarinet.toml with that requirement. So if we go open that file, we can see right here, we have this project.requirements, and we can see that the requirement is listed there. The purpose of this is just so that we can mimic that actual like live deployed trait on our local mocknet if we were to run that. So we're not going to be using it much today, but there is this Clarinet integrate command. I'm not going to run it because it takes a minute to get started, but this will basically create a mock version of the entire Stacks blockchain on your local, and it even has a mock Bitcoin node running too, just to make sure it's as close to the actual mainnet as possible. And that this clarinet.toml file, like this project requirements, will make sure that we have this trait available to us in our local mocknet. So that's what the purpose of that is. And then let's actually start getting this set up. So we'll start by looking at the project structure on the side. And what this does is it set up that clarinet.toml, which has some config stuff that we don't need to go into right now. We will get into this a little bit in a minute, but the rest of it is not super relevant for this particular tutorial. It has a test folder. We're not going to do testing in this one, but the Clarinet has a testing harness built in that you can use Dino for testing your smart contracts. And then it has a contracts folder. This is where our smart contracts will actually live. And then a settings folder. This is how we can configure how we want our like local DevNet to be set up. So these are all just mock accounts that get generated randomly when you create a new Clarinet project that will populate the test accounts on your DevNet. So the next thing we want to do is we're going to create this new contract, and we're going to do that with Clarinet contract new, and we're going to call it Amazing Aardvarks. That's going to be our NFT project. Hit that. And then so what this did is it did a couple things. One, it created this clarity file in the contracts folder. And then the other thing it did is it also created this default testing file. And so this kind of is a scaffolding to get you set up with what you need for testing. Again, I'm going to provide a link after the workshop that'll kind of provide places to dig more deeply into all this stuff since we're not going to be able to cover it. But we are going to jump into the clarity file, and this is where we'll spend the rest of the workshop, is building out this smart contract. So we're going to delete all this, but it does just provide like a suggested framework for how to organize your contract. Most projects I've seen do generally adhere to this structure. Again, everything is at the root level, so you would basically just be putting things just in an order that makes sense, primarily just for readability's sake. You do have to have constants defined either at the beginning or at the end. They can't be defined like in the middle of in between functions, so that's the only structural thing that I believe is actually like enforced. But just like most languages, it has a concept of constants, which are just pieces of data that can't be changed, and then it's got data maps, super similar to a mapping in Solidity, and then it's got variables, just traditional variables that can be changed, and then private and public functions, and then they also have read-only functions. So a lot of the same stuff that's pretty common to most smart contract structures. We're going to delete this for now and start actually building this out. So the first thing we need to do is we need to actually implement the trait that we pulled in via the requirements. So we're going to do the opening parentheses to get the function call started. We're going to call the implement trait function.
Kenny?
Yep.
Do you want to zoom once or twice?
Oh, yeah, sure.
Yeah, one more will probably be good. Yeah, there you go, man.
Cool, I'll get rid of sidebar too. One more thing I forgot to mention is that there is there's a Clarity extension for VS Code. So if you go to VS Code and search Clarity, oh, it's not showing up. There's this Clarity code for, I don't know why it's not showing up in my search. I'll find the link to that too and send it. But there is like an official Clarity, oh, here it is right here. So it's this one. It's this Clarity for Visual Studio Code by Hero Systems. So this will provide syntax highlighting and auto-suggest for, for the function, that kind of stuff. So if you see, like when I'm typing something, if you see it pop up as an auto-suggest, that's why. It's because I have that enabled, which provides some nice syntax highlighting too. So what we need to do here is, again, we need to paste in that same address that we pasted into our config setup, but we need to prefix it with the single quote character. This is just how principles, which are analogous to just addresses, they're just called principles in Stacks and Clarity. This is how we actually reference those. So you denote it with this little single quote, and then you paste the address in after that. And then this right here is the contract identifier, and this is the trait identifier. So if we were to take this off, this would be referencing a contract. So it would have the address and then the identifier, name of the contract. And then we add this on there, that's the name of the then trait that we're then implementing from that deployed contract, if that makes sense. So next thing we're going to do is we're going to start taking advantage of some of these built-in token types into Clarity. And so we're going to define a non-fungible token. And the NFT name is Amazing Aardvarks. And the NFT identifier type, we're almost always going to want to make this a uint, which is just a positive integer. I've actually never seen a project that did anything but this. That's by far the most common one. Haven't yet run into a reason to not do it that way. But this is going to be the unique identifier that will actually identify the NFT. And so this function by itself gets us a lot of built-in functionality. So we'll implement some of these in the coming functions, but this will right out of the box. It gets us built-in functions like mint, transfer, get owner, get last token ID, or not get last token ID, that's in the trait, but some of the basic NFT functionality you need, like minting, transferring, burning, that kind of thing. Those are all built-in functions, and by setting up this non-fungible token, we now have access to those on this Amazing Aardvarks collection. So the next thing we need to do is we need a way to track this identifier and iterate on it and update it every time a new NFT is minted. So we'll track that with a variable. We do that with define data var, and then we'll go ahead and name that last token ID. And then we have to give it a type. Clarity is a strongly typed language, so in a lot of the functionalities like lists, you can't mix types, and then you also can't like perform certain operations on mixed types. So like if you tried to add an int and a uint, it would give you an error. You would need to add two ints or add two uints together. So the type here will specify is a uint, and then we're gonna start that out with a default value of 0. Also note this little u right here. That's just how we indicate that this is an unsigned integer and not just a normal integer. So we'll get that set up, and then we'll actually update that here down below. And then we just need to set up a couple of constants. So the first one we're going to do is contract owner, and we're going to assign that to TX sender. And this is another super common pattern that you'll see in most Clarity smart contracts, is setting up this contract owner at the beginning. This is one of the first constants. And what we're doing right here is we're setting it to the TX sender. So the basic process for this is on deployment, TX sender is going to be set to the contract deployer. So this constant will be set to whoever deploys this contract, and then we can utilize that in further functions to verify. Like, for example, for this one, we'll be checking to see that only the contract itself is allowed to mint new NFTs. And so we'll add a check there to make sure that the current TX sender, when we call the mint function, matches the contract owner. So this is a keyword that will correspond to the principal of whoever is currently sending the transaction.
Is it required to be called that, Kenny, or has it become like a norm for developers in the space?
Yeah, no, you can call it whatever you want. It's just kind of a norm, just kind of a accepted custom. This is what most people call it, but this is not like a hard enforced paradigm or anything like that. This can kind of be called whatever you want. This keyword is right here. This is like a set clarity keyword, but this right here is what we're actually naming the constant, and this could be called whatever we want. But this keyword right here, the tx-sender, that is the like defined keyword in Clarity. And then the next one we're going to set up is this one's going to be an error. So we'll kind of get into how error handling is generally done in Clarity. Again, this is not like a hard requirement. This is just kind of a coding style best practice that has evolved in the Clarity ecosystem. Is we're going to set up a constant called error owner only, and what we're going to set that to is an error type, and we're going to give that a code of error 100. And then we're going to do something similar down here. We're going to make another one, and this is going to be not token owner, and we're going to set that to 101. So we'll see how this will come into play down in one of the other functions when we actually implement this error handling. But basically what this will do is it will allow us to do some error handling where we can return one thing if something succeeds, and if something fails, then we will return this constant, and then that will give us on our end when we're testing it, that'll give us this error code so that we can then reference it and say, okay, what is this error code actually getting me? different people do this different ways. This is kind of a personal preference depending on how you actually want to name these, but this is just one pattern that a lot of people like to use that'll make a little bit more sense once we actually use it. So now we're actually going to implement the NFT functionality. So this is where we'll kind of see how traits work. But remember that traits are only used to define what our smart contract needs to look like. We're still responsible for actually implementing how it does that. So they're mostly used to just define those standards. They're not meant to handle the implementation, and this is by design. We want to handle that implementation ourselves. So if we go back to this deployed trait, the first thing we need to implement is this get last token ID. So let's go ahead and do that, and this can actually be a read-only function. So we're going to do define read-only, and that's going to be called get last token ID, and then the body of that, delete that, enter. What we're going to do here is we're going to return a value of OK. This is a response type that basically means that the function call was successful. This is sort of the opposite of if we were to return an error type. We're just saying here everything worked. And as a result of that successful function call, we are going to create, this is basically just a getter for our last token ID variable that we set up. So now with this, we fulfilled that first requirement of implementing the last token ID function from that trait. So now any application that uses our smart contract is going to know that we rely on that trait, and so they're going to know how to actually interact with our smart contract to get the information they need about the NFTs. So this is also kind of where we look at like everything in Clarity is just a list inside of a list, and basically everything is a parameter being passed to a function, including the function body itself. So what we're really doing here is we're saying we're going to create a read-only function, and we're going to pass in the name of that function and the body of that function. And then that's what's actually going to create our read-only function right there. So the body of the function is actually kind of a parameter in itself.
Is there any concept of like scope? So if I'm looking at this as like a JavaScript developer, right? When I see brackets, I'm thinking of scope. Is there like a concept, similar concept of scope in Clarity, or is everything, is literally everything at the global level?
So it will basically be, the scope could be thought of as basically where the data is defined. So like anything defined right here at the root level, this is going to be available everywhere. Anything that we define inside of a function is going to be available inside that function. So the scope is by default wherever that thing is defined. And there's a function down below that we'll look at that will kind of show what that would look like if you were to define something within a function and how you would like use that in the context of that function. But that's how scope is handled in Clarity. It's basically wherever it's defined, that's where its scope is.
Okay, cool. Yeah, that makes sense. It's just the syntactical difference is like messing with my JavaScript brain a little bit.
Yep. Yeah. Same. It did the same thing to me. Okay, cool. So next one we're going to define is we need another read-only function. This one's going to be the Get Token Uri. So where this one is going to be far simpler than it would be in a real project because we don't actually have a website or anything to reference our token with. One thing that is going to be a little bit different though with this one is we actually do have parameters to pass in where we didn't with this get last token ID. And so where we're going to do that is inside of where we name the function, the second part of that is where we actually define our parameters, and we'll do that with more parentheses. And we are going to name this parameter token ID, and we're going to give it a type of uint. So this is saying we're defining a read-only function named get token URI. It's going to take a single parameter called token ID with the type of uint, and now the next parameter and quote unquote that we're passing in is going to be the actual body of the function. For this, we're going to return nothing because we don't actually have an interface to view our NFTs. But what we would basically do here, this is one of the things that's going to be fixed in the next version of Clarity, but it's a little bit of a pain to like concatenate a number into a string. So where normally what you would think of as doing something here is you'd have a constant defined where you would have like an IPFS root URL, and then you would just throw in the ID that you're trying to get there. We would do a version of that here, but the passing in of the ID would need to be done actually on the client side. So what we could do here, hypothetically, is we could have a function that looked like this. And this looks super weird and it's kind of complicated, and this is going to get a lot easier and less complicated in the next update of Clarity. Stacks is kind of going through a relatively large upgrade right now that should be done by the end of the year that will fix some random little quirky kind of annoying issues. But basically what this would be doing is it would first put together an IPFS root variable that we would define up here. So we would get our IPFS root, define that up there as a variable. That would pull that and it would concatenate it with this string literal. So this would be actually putting that string literally into it. And then it would concatenate this .json on top of it, and that would actually return that. And then on our client side is where we would swap that bracket ID out for the actual ID that our client was requesting. So it's a little bit, sometimes kind of a funky way of thinking about it, which should get a lot easier in the next version of Clarity. But if you're curious, that's how you would do that. If you wanted to actually get a URI, which we don't actually have for this specific example. Next one we need to implement is the get owner. And so here, that's going to be another read-only. So we can define read-only. We're going to call that get owner. And in that one, we're going to pass in another token ID. It's going to be a uint. To implement that one, we have a built-in NFT get owner, and so we're really just going to create a wrapper around that. So this is another kind of pattern that you'll see when you're implementing traits with these custom token types that are built in, is a lot of the time all you really need to do is you just need to put in a wrapper around that token type, but it's just making sure that you're enforcing, you're sticking to that trait that you've defined. So all we're going to do here is we're going to define this NFT get owner function. Question mark basically just indicates that something is going to be returned from this. I'm going to do the NFT collection name and which ID we want. And what this is going to do is this is going to return the principal of whoever owns the NFT with this particular token ID. So next one down is transfer. That's the one that we have to implement last. This one is not going to be a read-only. This one is going to be a public function. And this is going to be in charge of just transferring tokens from one principal to another. So this is where we'll start to look at a little bit of like the address checking to make sure that we're not sending something that we shouldn't be allowed to send. So this one is going to be called transfer, and this is going to take in a few parameters. So the first one it's going to take in is the token ID that we're going to be transferring. Same as the other one, it's going to be a uint. Next one is it's going to take in a sender. And this is going to be a principal type. Again, this is analogous to an address. And then finally, going to take in a recipient, which will be another principal type. And then next, we need to implement the body. And remember before when I was talking about how basically everything in Clarity is just a function being passed to another, or a parameter being passed to another function. So because of that, function bodies can't actually be more than a single expression. So the way that we handle functions that need to have multiple steps is we can start a begin block. And what this will do is this will wrap everything in a single expression, and it will just execute it step by step, line by line. So inside this begin block is technically the parameter that's being passed to this defined public function, and then we can contain the body of the function within here. So the first thing we want to do here is we'll introduce a little bit of control flow. We're going to do an asserts, and this exclamation point just indicates that this is checking to see if the condition is true, and it will take one of two actions if it is or isn't. We're going to do the is equals, pass in tx sender and sender. So what we're doing here is we're checking to make sure that the person sending this transaction, which is a built-in Clarity keyword, is the same as the sender parameter that we're passing in. So if I'm trying to steal somebody else's NFT, this check is going to make sure that I can't actually do that, because if these two don't match, then what it's going to do is it's going to return that error code that we defined up above, not token owner. And what will happen here at this point is not only will execution halt here, but anything that happened before this will be reverted as well. So the entire function gets reverted if something returns an error. I know we're running out of time, so I'll try to speed through the rest of this. But the next thing we're going to do is we're going to implement this built-in NFT transfer, which is going to take in our collection name, the token ID we want to transfer, who is transferring it, and who they are transferring it to. So the reason that we can call this function safely is because we have this asserts defined right here. If I save this right now, it's going to give me a couple squiggly lines, and what this is doing is Clarinet has something built in called a check checker. that will warn you if you have unchecked inputs. So right now, if I go over to problems, this is going to tell me that I have a use of potentially unchecked data. In this case, this is basically just meant to serve as like a heads up to the developer, like, hey, make sure this is cool. Since I'm checking the sender here, this is actually fine, and we're okay with having this unchecked data because we've already checked the sender here. And so what we can do in that case is we can add this little annotation that's a filter that will say, you don't need to worry about the token ID or the recipient variables because those are cool. And then if I save that, that error goes away.
Reminds me of TypeScript no check.
Yeah, exactly. Yeah, super similar. You can also add, there is like an allow all, but this is generally like the preferred way to do it.
More explicit rather than just like, let me off the hook for not doing it properly.
Right. Yeah, exactly. Okay, cool. So last one we'll implement is the mint function. This is not required by the trait, but we're going to add it here because it has all the safety checks already built into it. The mint function does, but we're going to add it here as more of like a convenience function and to illustrate a couple of the other pieces of clarity. So we'll define public mint, and this is only going to take in one recipient, and it is going to be principal type. And the reason we're creating this convenience function is because we only want the contract to be able to actually mint new tokens. And so that's why we would, in particular for our use case, we would add this. That may be different for a different project, but that's what we want to do here. So what we're going to do here is we're going to introduce a new function called let. And let does two things. The first thing it does is it takes in a set of variables to define. So what the first thing that this let function is going to do is it's going to define token ID as the result of whatever function we pass to it. So what we're going to do here is we're going to set up an addition function. We're going to get the last token ID variable, and we are going to add 1 to that. So what this is going to do is this let function is going to first look at this chunk, and it's going to say, okay, I need to set up this token ID variable to be equal to the result of this expression, and then I'm going to use the result of that in the rest of this function as in that context. So this token ID variable is going to be now available to the function body that we pass in after this. So this is a lot like begin, but with the extra step of defining these variables to use in this particular scope. So with that said, to actually define the body of the function, what we want to do here is we want to make sure that whoever is calling this function is the same as the contract owner that we defined above. And so what this is going to do is it's going to make it so that the contract is the only address that can actually mint new tokens. Users can't mint new tokens. And so what we would do in this case on the client side is you would call this contract and initiate the transaction, and the contract would basically mint on behalf of you. And then next thing we do is we actually call that built-in mint function. I'll explain this try in just a second. But we're going to mint that NFT from this collection. We're going to mint the new token ID that we generated up here, and we're going to give that to the recipient. Then the next thing we need to do is we need to update that last token ID variable so that we can correctly iterate and make sure that we are tracking exactly that we're tracking the right identifier on our token. And then we have to have a return response, so we'll just return OK with token ID. What this try block will do is it will attempt to unwrap the first argument. And when I say unwrap, I mean this question mark means that this function could return multiple things. And so this try block will check to see, did it return a success message? Did it return an error message? And if it returned an error message, it will halt execution and revert everything and return the error code to you that the internal function returned. If this internal function returns OK, then try just says, OK, let's move on to the next line, and does the rest of the function. So that's kind of how our mint function will work. And then just a couple real quick things. If we run Clarinet check here, this is going to give us that our contract passed. One quick thing to look at is that if we were to like get rid of this, we were to comment this out, we'll get this error. And if we run Clarinet check again, it's going to give us that error. Oh, I just have a typo here. That's my bad. Hold on, let me fix that real quick. So let me fix that. Okay, and then we're also getting another untrusted data input. we can solve that the same way we did before. Put that right here. The center button isn't working. Go. Over there. Did that the wrong way. There we go. Okay. Now we run Clarinet check again. So that's the other nice thing about Clarinet is you can check your contracts right there and it'll tell you, hey, this function doesn't exist. And then 2 contracts checked there. Let me comment this out. Run that again. And it's going to tell us that we have an invalid signature for get owner, and that's because we're not adhering to that trait that we said that we have to adhere to. So that's why it's giving us that error. It's actually not going to let us deploy the contract with that. So it's up to you. I know we're over time. If we want, I can go over like just quickly testing this in the console to kind of show like what this would actually look like in practice. Or I can drop like some next steps links and we can move on. Totally up to what you guys want to do. We'll get either way.
I think we're fine for a little bit more time. There's some questions backed up in the YouTube stream, which I can maybe ask you afterwards because I think I missed them. I wasn't picking up the feed, so the context is probably way off. So maybe
okay.
How long do you think it will take to do the testing in the console?
Should just be a couple minutes, just to kind of, we're just going to call a couple of these functions just to kind of show what it would return.
Yeah, go nuts, man.
The built-in console, we'll run that, and that'll drop us into a super simple test network. We've got our contracts here, our test addresses here, and so what we'll do real quick first, I'm just going to copy and paste this instead of typing it out just to save some time. But what we would do here is we would run this contract call function. And we're saying we're going to call the amazing aardvarks contract, we're going to call the mint function, and we're going to pass in this tx sender as the parameter. When we run Clarinet console, we're automatically dropped in as the deployer, so this will run fine, and then it will emit this event, and it returns the generated token ID. So then the mint function works. Then we can go ahead and we can transfer it. So we'll do the contract call again, contract name, transfer function. We're going to transfer the NFT with the token ID of 1 from the transaction sender to this address, which is still valid. We can hit transfer there. It'll give us OK true, and it'll give us this event, which we can read from the client. We can interact. We can use the Stacks blockchain API to read events like this and do something on the client based off of it. And then last thing we can do is Clarinet has a couple built-in cool functions like get assets maps, and this will kind of allow us to see who has what. So like we can see here, this address that I just transferred to has 1 of the amazing aardvarks. They've got this many test stacks. So that is the kind of rundown of everything. So yeah, we can get to questions. I'll stop sharing my screen because I think that's about it for that part. And then I'll post in one more link just in the Discord chat. We can post this wherever. But just before we get into the last questions, I set up this page as just like a start here page for Stacks. So this will kind of, if you're interested in learning anything else, if you have a project idea you want to work on, you want to get a grant, all that kind of stuff, this will kind of direct you to where you need to go to learn what you want to learn and get done what you want to get done.
Sweet. Amazing, Kenny, man. That was super interesting. I was like trying to maybe the mistake of trying to map it to my existing thinking as a programmer. Like you, I was like super focused on JavaScript beforehand, but like as the functions you were writing evolved, the patterns started to make sense. I've always shied away from really strongly typed functional stuff. I don't know why, really. I think mainly, like you said, because it's mainly academics that tend to use it, so it kind of terrifies me. But
yeah, that's right too.
But yeah, super interesting. One thing that was just on my mind there before I forget it is, say the way that NFTs on Ethereum might store their media file on IFPS or Arweave. How's that done in Stacks?
So you can kind of do something similar. That would be kind of a separate process where you would you'd set up your files on IPFS separately. So there's an NFT project called Gamma that uses IPFS, I believe, for their image asset hosting. And they basically handle the file upload on the client side with IPFS. They use Panada to pin it. And then what you'll do is in that function that we looked at, the Get Token Uri, you'll basically set up you'll pull your IPFS root from your IPFS root domain. You'll assign that as a constant or as a variable in the contract, and then you'll create like a mock URL with the placeholder for the ID, and then on the client side, you would call that get URI function, which would return the base URL, and then you would pass in and manually swap out the ID on the client side there. Does that make sense? Kind of.
Yeah, I think so. And
do you? A bit of a weird workaround right now. It's getting that issue. There's gonna be a built-in function in Clarity being added in the next update that will make that a little bit less weird to work with.
Nice. And do you have like I'm just coming from like my Ethereum world, mate. Is there like a concept of like doing like generative NFTs where everything's done in the smart contract that then produces like some kind of visual asset? Or
I don't actually know if there's a project like that on Stacks yet. I'm not entirely sure about that. I don't see any reason why it wouldn't be able to exist, but I don't know if anybody has made a generative art project like that yet.
Interesting. Stinks of an opportunity for anyone listening. So some of the comments that came in on the YouTube live chat were, where are we? Give us an example of an attack where Bitcoin would be shielded, which I'm assuming is talking way back to the start of the talk where you were mentioning about like the balance between security on Stacks and Bitcoin. I don't know if that question makes sense or.
Yeah, so an example that I sometimes like to use is way back towards the beginning of Ethereum's existence, there was the big the DAO hack that resulted in the hard fork.
We don't talk about that anymore.
Yeah, right. But one thing that could have mitigated the massive impact of that is separating the money and smart contract layers. And the reason some people do disagree, and so if your opinion is different, that's totally fine. But this is the way that I looked at it. Was the reason that had to result in a hard fork is because it was such a large amount of money that it kind of decimated the Ethereum economy at the time. And so if the economy is safe, you can deal with the smart contract bugs and the smart contract errors that happen separately, which is also kind of the benefit. A lot of Bitcoiners don't like the fact that Stacks has its own token. There's a lot of Bitcoin maximalists that get kind of crazy about that. But one of the other things about that is that since you're using Stacks as sort of a gas token on the smart contracting layer, if something were to happen on the smart contract layer, that Stacks token would be at risk, but the person's Bitcoin that they are holding on their address non-custodially that may have triggered that Stacks contract, that's not going to be touched at all. It's not possible for and that's why the write problem is so difficult, because we have to figure out a way to change states to the Bitcoin chain that don't actually affect the Bitcoin chain itself, which sounds like it's impossible. And there are some weird ways that we can kind of work around it, but we basically use Stacks as like a trigger so that there's no way, unless the person on the Bitcoin side is directly sending their Bitcoin somewhere else intentionally, there's no way for like a vulnerability in a Stacks smart contract to then allow them to steal somebody's Bitcoin.
Yeah, that makes sense. Yeah, and it's like it seems completely logical now, right? Like when you think about it after years of seeing this stuff happen, because you've got like is it Celestia, like people talking about like modularizing the blockchain.
Mm-hmm.
I don't know if they're going down like a similar path to that, but it kind of completely sounds like that makes sense.
So that was one of the things that really drew me to it at the beginning, was that separation of concerns and having the simpler but arguably more secure settlement money layer.
Yeah, it makes complete sense to me. There was another question from Francisco about is Clarity somehow related to Rust? And then someone else, excuse me if I'm getting the name wrong, but Benaya said it's Lisp based. And then a follow-up question from Francisco was, does Lisp have optional and response traits?
So I'm actually not sure about that. I'm not super familiar with Lisp at all. Clarity is really my first exposure to this style of programming. And I wasn't involved in the creation of the language, and I've never used Lisp. I just know that that's what it took a lot of inspiration from. And so if there happen to be Lisp developers, that can kind of give them a little bit of an idea of where it came from. But personally, I'm not familiar with Lisp.
No worries, me neither, man. I was struggling to. If you didn't understand that question, I would have struggled to reframe it for you, I think. And then Binaya has then just followed. Has just said another question. I'm assuming this may make more sense to you than me, which is, can you also talk about an exploit that occurred with one of the pool of R-Kadiko and how the risk was minimized to recover funds? Does that make sense?
Yeah, I just can't remember what happened off the top of my head. Yeah, that might have to be something that was that. But did you say that was Benaya that asked that?
Benaya Tripathi, yeah, on YouTube.
Okay, cool. Yeah. Yeah, I don't know the answer to that off the top of my head because I cannot remember exactly what caused. I'm trying to look up. I know there was an article that described it. Trying to pull it up real fast so if I can just kind of jog my memory of what happened. So here, I'm gonna post this. This is a walkthrough of exactly what happened and what caused it. But at a high level, basically what happened is that there was a swap that was created, and so two fungible tokens were created, and they had an LP token, but the contract didn't correctly check that the LP token was a valid one to go with the pair of separate fungible tokens. And so basically what happened is the attacker could provide an already existing LP token, which shouldn't be associated with the two separate tokens, and then they minted a high amount of those LP tokens and then were immediately able to swap them for separate fungible tokens, even though the LP tokens never should have actually existed in the first place. So that's a little bit, I think that's the hack they're referring to. That was a little bit convoluted, but the article kind of goes into it a little bit more, and it's also a good example of a potential Clarity vulnerability and what kind of stuff can happen in Clarity. But yeah, that was kind of a convoluted answer because it's been a while since I looked at it, but that article should help clear it up.
Hey, Kenny. So sorry, I was just speaking and I was muted, as we always are on voice calls these days. I was gonna say, I was saying that for me, coming from a position of zero knowledge of stacks and how the programming and smart contract model works, all of that is really quite super clear to me now at a high level. So really grateful for you going into that and through that. I'm still terrified of strongly typed functional language like that, but hopefully someday when I'm got a bit more time to do more coding, I can go down the rabbit hole and and find the goodness that I'm sure is there. So what's the best way for folks to kind of talk to you, to find you online and maybe ask questions, and then second to that, maybe I'll message you afterwards to make sure that the description in the YouTube video gives folks access to the right kind of resources and links. But is there any place, second question, any place where you would suggest people start down that journey into stacks? I know you shared that link before. I don't know if that's the right place or.
Yep. So yeah, that second question first, that start.stacks.org link that I shared is definitely where I would suggest everybody start. As far as getting in touch with me, I have an Arweave perma page set up. I just posted the link there. But that has my Twitter account, GitHub. I have an account on Dev where I write. And then the other place that would be a good place to reach out to me is in the Stacks Discord. So I can post the link to that here as well. But yeah, I am relatively bad at monitoring channels, but if you tag me in something, I'm usually pretty good at responding to those.
You and me both, man. Yeah, man, that was awesome. Thank you very, very much. I will sync up with you afterwards just to make sure that we've kind of got the right context there for folks that come and discover the video later. But any final parting words?
No, I don't think so, other than just I am the developer advocate of the foundation, so it's kind of my job to just talk to and help and support developers. So please, nobody, if you have any questions at all, don't hesitate to reach out to me. My DMs are open on Twitter and Discord. So yeah, reach out with whatever questions you have.
Awesome, man. Really, really appreciate it. Thank you very much.
Yeah, thank you. It was fun.